Very good evening. My name is Nathania Grace Mahadevan, metric ID CB18166, an undergraduate student in Bachelor's of Computer Science, majoring in software engineering. So my system that I have presented to Citrex is my final year project, which is the home flood alert system using IoT device. I'm from the Faculty of Computing from University of Malaysia Pahang, and my co-inventors are Dr. Noor Shamsiah and Dr. Anis Farihan. So first of all, let me go to the product background. So the home flood alert system using IoT device is a system which with mobile application where it uses water level sensor and Node MCU as ESP8266 as the microcontroller, which is the IoT device, to actually sense the water level at 3 different levels and also communicate this information with database and send a notification to mobile device. So the mobile device has 2 users, multiple users, which is one is civilians and the other is authorities. So this alert notification, so the water level sensor will actually detect level at 3 different levels, which is the safe level, the medium level, and also the dangerous level. So once it reaches the dangerous level, an alert notification will be initiated via mobile application, the FloodSafe app. So this system actually uses the Arduino analog water level sensor to detect the water level, and it will process in the Node MCU ESP8266, and it also uses LED lights as well as a light alert and send notification via the mobile application of the Safe app. So this app can receive notification, and civilians can initiate call to the fire department or other authorities in case of emergency of sudden floods. So the methodology that I used for this project is the agile methodology, where I gathered requirements from the Department of Irrigation and Drainage of Pahang. Then I gathered requirements again from the civilians around flood areas in Pahang, specifically in Kuantan. Then I created a use case diagram, context diagram, flowchart to actually expand the requirement analysis. Analyze the requirements that I've gathered. So then after that, I went into design. In design mode, I designed the user interface for the mobile application using XML and Android Studio. And I set up the hardware. I set up hardware where with the Node MCU, LED lights, diodes, and also the water level sensor with jumper wires as well. Then I went into the developing phase where I programmed the mobile app using Java and Android Studio. So then after that, for sensor configuration, I use Arduino IDE and I program it using C++. So the database that I use for this system is a Firebase database to store data. So for testing purposes, I did user acceptance tests and also integration tests and also functionality tests. So for user acceptance tests, I created a form where I sent out to both users and the authorities, which is the Department of Drainage and Irrigation, to test out the system and fill up. So the system also was reviewed by them and I received feedback from them. So this is the flow chart of the system where once you start, you can choose your user type, if you're a civilian or an authority. So if you're a civilian, you straight go into login page where you can click on the register button where you register, and then you log in back, and then you can set up your profile, and then you can also set up your authorities contact. And then once the water level has reached a level which is dangerous, you receive a notification, and then what the civilians can do is they can initiate call to the authorities. If they initiate call, it will direct them to their call page, call app, and then they will initiate calls straight to the authorities. So they can program their calls inside this mobile application. And also, if let's say they don't, it will end just like that. So for authorities, also the same, they can set up profiles, and they can also send email notification to all the departments that they are actually involved in the flood to save civilians. So these are the results. This is the prototype which I have set up with the Node MCU, LED lights, jumper wires, and also water level sensor. And this is the Arduino monitor results, where the monitor will actually detect each level as the water level changes from the water level sensor. So the water level sensors go against resistance. So the higher the water level, the higher the current it will detect. So warning level is water level reading 0 to 320 is safe, and 320 to 420 is in the warning level. And if it's more than 420, it will be in the dangerous level. So this is the notification page where if user receive notification when the water has reached the dangerous level. And here's the sensor reading page where the sensor reading will change as the water level increase or decrease. So the markability of this system is that recent flood events actually have caused a lot of loss and damage of belongings. And actually it shows if, let's say, civilians have an early alert system or early alert application, they can actually reduce damages by preparing earlier of the impending flood. This system actually can be installed in rivers, drainage, and river basins. So wherever there is a flood, wherever the cause of the flood is, this system can be installed, and it can also detect the flood level. So the originality, the novelty of this system is that a flood alert system, which can be accessed by both civilians as well as the drainage department. So the access is not only granted for the authorities, but it's also granted for civilians also to check how much water level has rise. Civilians can feel a sense of safety in that way. So it's through a mobile application which is easy to install and download in their mobile application. So far I've only downloaded for Android Studio. So in further works, I would like to do it for also iOS. Thank you very much for your time.
Very good evening. My name is Nathania Mahadevan, metric ID CB18166. So this is my home flood alert system using IoT device prototype. So this, first I would like to introduce the components to you. This is the Node MCU sensor, Node MCU microcontroller. These are the LED lights, green for safe level, yellow for a warning level, and red for dangerous level. So these are the diodes to control the electrical current to the LED. And then this is the water level sensor that will sense the level of water. So it is connected to the pins in the Node MCU board. So this is connected to my Arduino IDE. So this is my Arduino IDE. So these are the codes that I have done for to test my Arduino. So these are the libraries that I have downloaded, and this is my connection to my Firebase. Here is my app, my Firebase database, and also my Firebase key, authorization key. And then here is connected to my Wi-Fi, so my Wi-Fi and password. And then these are my definitions of pins. So the green LED is connected to D7, the yellow LED is connected to D6, the red LED is connected to D8, and the sensor is connected to A0. So these are my thresholds. So the medium threshold is 320, and also the high threshold is 420. So then this is my sensor configuration. And now for my if and else statement. So for water value, it will read the sensor. So and then it will print out sensor water level. So if water is 0, so the water level will be 0. So then the green LED will be low. Yellow LED also won't light up. The red LED also won't light up, so it will be empty. And then, but if the water is between 0 and the medium level, which is 320, the water level, it will send to Firebase, and then the green LED will be high. and yellow LED won't light up and red LED won't light up. It will have safe level and it will print out the how much water is there. And then if water is between medium 320 and the water is between 420, it will be yellow LED will light up. So it will say warning level here and print out how much water is it. And then if water is more than 420, so the red LED will light up and it will print out dangerous level. So now I will show you what happens, the reading of the water level. So now I'm going to pour some water here. So pour some water. So pour some water. So it's still in green because it indicates safe level. So now still safe level. So now I'm going to pour more water. So now let's check the serial monitor. So it has reached more than 320. So it's warning level now. So the LED also has turned to yellow. So I'm going to add even more water. Okay, let's check the serial monitor now. So it takes time to read. So it reaches more than 420. So it will read dangerous level. So the LED has also changed to red. So this will also be recorded in our Firebase database. So I've already set here. So it's reading. It will take time to read because connection. So I'll be reading. So I have water level here, and then so in the serial monitor it will keep changing. So now we're waiting for the notification part. So we're waiting for the sensor to detect the notification, the water level. Okay, now the notification has reached. So when you press the notification, it will open to the app. A very good evening. So today I will show you the Gyre Flood Safe app for the user civilians. So first we have to choose our user type. So we'll choose civilians, and then before you log in you have to register an account first. So you can put in your full name, you can put in your NRIC, and then you can put in your phone number, and then you can put in your address. So I'm going to put all these are just for testing purposes, it's not real. So I'm going to put and then you can put in your email. Okay, your email has to be a valid email, okay, to send verification code. And then your password. Okay, password has to be 7 characters. So let's say if I put just 6 characters and I confirm password with 6 characters, so and I press register, so it says password must be more than 7 characters. So I'll put 7 characters now. Okay, then I'll press register. So now you have registered. Now you can log in. So you can log in with your email and then your password, which is the 7-character password. So log in. So here your name, IC number, Taman, your address, and your email will be shown. This is your profile. So if you want, you can send your email verification, and then it will disappear. So you have to verify your email through Gmail. So now we can edit profile. So let's say we want to edit .v, and then we want to change this, so maybe we put as 6, and then we want to change this, put as 5, and then we just put Taman Seremban, and then okay, that's all. So now we click save. So say profile updated, and then you can see it is all changed. So now we go to alert pages. You can log out if you want to. You can go to alert pages. So here the sensor reading will be red. If let's say water level reading is more than 320, then civilians can call the authorities. But before you call authorities, you have to add your contacts. So you click add contact. So you can add fire contact, your local fire department. So let's say it's 106453. I'm just going to put a dummy number, and then DID is the Drainage and Irrigation Department contact, so you can put the contact here. And then rescue contact can be any part of NGO and rescue teams, so you can put their contact here as well. So then you save their contact. So now you want to call the authorities. Let's say it's reached more than 320, you can call the authorities. Okay, let's say you want to call fire department. You just have to click this green button over here with the call, and immediately you can call. This number is not in service, so unable to call, but if you put a number, it will be able to call. Page. So I'll go back and I'll log out. Okay, then I'll go to the login. So thank you very much.